Welcome to Unit 4, Lesson 5, Negative Rational Exponents. Let's investigate negative exponents. Again, take a look at our exponent laws. We're going to be concentrating on this one today. Okay, let's look at our warm-up. 9 squared equals 9 times 9, which is 81. 9 to the negative 2. Now, the first thing you do here is deal with the negative exponent. So 9 over 1 to the negative 2. The first thing, the negative exponent flips a fraction upside down. So that gives us 1 over 9 squared, which is 81. 9 to the 1/2 is equal to the square root of 9. The 2 goes here because it's the denominator is the index. The numerator is the exponent, but mathematicians are lazy. They don't like writing ones. And it's understood to be the square root. There's no such thing as the first root. The square root is the first root you can take. The square root of 9 is 3. Positive 3 and negative 3. Positive numbers have 2 roots. 9 to the negative 1/2, just like the second one, we flip the fraction upside down. And this is 1 over 3, plus or minus. Okay, using a calculator, 2 to the negative 2 is 1 over 4, which is about 0.25, not about, it is. 2 to the negative 5/3 is about 0.3. 2 to the negative 4/3 is about 0.4. So approximately, these are approximations. 2 to the negative 1 is 1 over 2, which is 0.5. 2 to the negative 2/3 is about 0.63. And then 2 to the negative 1/3 is about 0.8. And 2 to the 0 is 1. So they want us to plot these points. So coming back and plotting the points, 0.25 is about right there. Then 0.3 should be halfway. And negative 4/3 is about 0.4. 2 to the negative 1 should be about halfway. And 2 to the negative 2/3 is about 0.63. And 2 to the negative 1/3 is 0.8. And 2 to the 0 is 1. It kind of curves up. It would just be better to plot y equals 2 to the x power in the calculator and see what the graph looks like. It's kind of hard to tell what it looks like. It may look like a straight line to you. It may look like a slight curve, but it looks vastly different on the other side of 0. Okay, let's investigate 2 to the negative 1/3. Write 2 to the negative 1/3 using radical notation. So we're going to handle A in blue, and B in green, and C in orange. Okay, 2 to the negative 1/3. The negative flips 2 upside down, so it becomes 1/2 and a cube root. Because the denominator is the index and the numerator is the exponent. Now, use exponent rules to write 2 to the negative 1/3 cubed in a simpler way. So we know when we raise a power to a power, you multiply the exponents. 2 to the negative 1/3 times 3 over 1 becomes negative 3 over 3, which equals negative 1. And 2 to the negative 1 equals 1 over 2. And then when you take C, they want you to take the numbers from that we estimated, and you get close to 2. No, 2 to the negative 1/3. Raise it to the 1/3 power. You should get close to 0.5. You won't get exactly 0.5 because we rounded it off, and irrational numbers never end and never repeat, so approximations are a little off. All right, let's investigate 2 to the negative 2/3. We have 1 over the cube root of 2 squared, which is 1 over the cube root of 4. Negative 2/3 times 3 over 1 equals negative 2. 2 to the negative 2 is 1 over 2 squared, which equals 1 over 4. And the same thing for C. So estimation, it'll get close, it won't be exact. Okay, any fraction can be an exponent. So what we have to do is look at this. For each set of 3 numbers, cross out the expression that is not equal to the others. So what I recommend you do is transform the first one so it looks radical. And maybe I should have highlighted it. Let's highlight it so it looks better. So transform the first one so it matches the other two. So start with A in blue. 8 to the 4/5 is the, sorry about that, is the 5th root of 8 to the 4th, which matches the last one. So these two match each other. Okay, 8 to the negative 4/5 for B is 1 over the 5th root of 8 to the 4th power, and that matches the second one. And then y'all look for that negative. Negative exponents do not make a negative, so this is the problem with the last one. Negative exponents do not mean negative. It means the fraction flips upside down. So for C, we're going to transform the radical to exponential form. Now, it's understood that this is a 2. That this is a 2. The index is a 2. There's no such thing as the first root. So roots start at the second root, the square root. So if we write this 4 to the 3/2, we see that the first 2 match each other. And then finally, 1 over 4/3 is 4 to the negative 3/2. And that was easy enough. We didn't even have to rewrite it. There's no negative with negative exponents. The negative does not go out front. Now, if a negative was already there out front, then the middle one. Negative exponents do not mean that the term is negative. Okay, for 2, what we got to do is change these into radicals. So for each expression, write an equivalent expression with only positive whole number exponent. That means 17 cubed. So they want us to transform the exponential into radical form. 1 over the square root of 31 cubed. The numerator is the exponent. The denominator is the root. And we don't write 2 on the index of square roots unless you need to see it visually. All right, so now change these into exponential form. So before you start to do anything, write a 2 here as a reminder. So we got 3 to the 4/2, and we know that 4 divided by 2 is 2, so we're going to write 3 squared, and we're going to leave it like that. Okay. This is 5 to the negative 6 over 3, which is equal to 5 to the negative 2. They said write an equivalent form in the form of a to the b power. They did not ask us to evaluate it all the way down to a single number. Okay, here's another grouping task. So let us pick our colors. We're going to do blue. No, let's not do that. Let's evaluate these first, and then we'll come back and highlight the colors. So we know that This is 3 to the 4th squared, which is 3 squared. And I'm going to leave it as 3 squared for now. This is 3 to the 2 over 2, which equals 1. So that's 3 to the first power. Now, when you take the square root of something squared, the radical just pops out. So hopefully we can recognize that now. This one is 4 to the, where did I get 4 from? That's the exponent. It's 3 to the 1/2 times 4 over 1, which is 4 over 2, which is 2. So this becomes 3 squared again. All right, this one right here becomes 3 to the 2 over 2 times 3 to the 2 over 2. We know 2 over 2 is 1, so that's 3 squared. Because when you add fractions, add the tops. If the bottoms are the same, 2 plus 2 is 4 over 2. 4 over 2 is 2. Okay. When you raise a power to a power, multiply the exponents. 2 over 1 times 1/2 equals 2 over 2, which is 1. So this is 3 to the 1. 3 squared just is 3 squared. 3 to the 4 over 2 is 3 squared. And finally, the same as the one in red. 1/2 times 2 over 1 equals 2 over 2, which equals 1. So this is 3 to the first power. So I do the math only with the exponents, and then I come back and add my base in. So now, which ones are like? I got 3 to the 1, 3 to the 1, 3 to the first power, and that is it. And all the rest of them are alike. All the rest of them are 3 squared.